We are continuing to learn about quadratics and how to solve them. We have learned how to graph, factor, and complete the square. If you get this packet out, it starts with solving quadratics by factoring and turn to Algebra 1 review radicals, simplifying radicals. We're going to learn how to solve by using square roots today. So this is the fourth way that we have learned or are learning to solve a quadratic. What is a radical? Yep, a radical tells you to take the square root, or it could be cube root, etc. So a radical is any given expression with a square root, cube root, etc. This is the radical symbol. List the first 20 perfect squares. A perfect square is a number that you can take the square root of. They start with 1. So in my mind, I'm thinking, what can I take the square root of? 4. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared, I think is 225, right? That's all I know off the top of my head. Is that the first? That's the first 25, isn't it? Or the first 20? Well, that's the first 15. All right. Case 1, perfect squares. Take the square root of the number. Case 2, non-perfect squares. Break the radical down using the largest perfect square that you can factor out of that, whatever's under the radical. Take the square root of the perfect square, leave the leftover under the radical symbol. For both cases, if there is a coefficient outside the radical, multiply this with any numbers you take out. So, what does that mean? If you have a perfect square under the radical, all you have to do is take the square root. What is the square root of 49? Is it just 7? It can be positive or negative, so don't forget your plus or minus. What's the square root of 225? We just said, what? 15, right? You can do these on your calculator too. What's the square root of 144? Well, because we have a number in front, we need to multiply 2 times 12. So the answer here is actually 24. When you have a number in front of a radical, it is multiplied. A radical is just like any other operation symbol, or like parentheses. If you have a number on the outside of parentheses, it's understood to be multiplication. Same thing with a radical. Number 4, square root of 4/9. Both of those are perfect squares, so take the square root of both numbers. Square root of 4 is 2, square root of 9 is 3. Same with number 5. Both of those are perfect squares. Take the square root of each number. Square root of 1 is 1, square root of 81 is 9. Again, number 6, both perfect squares. Square root of 36 is 6, square root of 121 is 11. Now, if we do not have a perfect square, that's when it's a little more complicated. Not really complicated, but involved. So, I can't take the square root of 112, but 112 does have a perfect square factor that I can take the square root of. What is a perfect square factor of 112? Look at your list of perfect squares. Are any of those factors of 112? You want the biggest one you can find. So 16 times 7 is 112. So we're going to break it down and make it 16 times 7. I know I can take the square root of 16. That comes out from under the radical. What's left over stays underneath. So that's what it was talking about up here, case number 2. Break the radical down using the largest perfect square factor. Take the square root of the perfect square. Leave the leftover under the radical. But after you take that square root, that comes on the outside. What's left goes under the radical. What about 245? What? 49 and 5. Take the square root of 49. That is 7. That comes out from underneath the radical, and the 5 stays underneath. A radical is just like any other operation symbol. So once you take the square root of it, the operation symbol is gone. A lot of people make the mistake, well, some people make the mistake of going square root of 49 is the square root of 7. That's not correct. Make sure you get rid of the radical for what you've already taken the square root of. What stays underneath is what you have not taken the square root of. Number 9, 5 times the square root of 72. What is the square root of 72? It's 36 times 2 because 6 times 6 is 36. They've already taken the square root of 36. That's how I know that number on the outside. And then I have to multiply that 6 by what? What's already there, that 5. All right, so, and then my answer is 30 square root of 2. Number 10, what's the square root of 45? 9 times 5, right? Square root of 9 is 3. Bring it out and multiply by what's already there. 5 stays under the radical. Square root of 250 is 5 square root of 10. And number 12, square root of 578 is 17 square root of 2. But I already have a 3 there, so I have to multiply the 17 by what's already there. All right, so that was a quick little review about radicals and square roots. Now let's see how to solve a quadratic with square roots. Okay. There are only certain type or certain forms of a quadratic equation that can be solved with square roots. They cannot have the b term. If it's ax squared plus c equals 0 or ax squared equals c, if you're going to solve with square roots, it cannot have a b. And you're just going to take the square root of both sides to find x. But it cannot have a b term. So the steps are isolate x squared, take the square root of both sides, simplify the radical, place plus or minus to indicate both answers. So first step is to isolate x squared. For number 1, we've got to get x squared by itself. How do I do that? Move that 64 over to the right by, yes, adding it. We need to add 64 to both sides. So x squared equals 64. How do I solve for x? The opposite. Remember, when you're solving an equation, you always do the opposite operation. The opposite of x squared is square root. So you're going to take the square root of both sides. Square root of 64 is plus or minus 8. Number 2, we've got to get x squared by itself. Remember, we're doing the opposite of, well, when we were simplifying expressions, we used order of operations. When you're solving an equation, you do the opposite order of operations. So instead of Jim Doss, we follow sad Meg. Meg will be sad if we don't follow order of operations. So we do addition and subtraction first instead of last. So I'm going to subtract 8 from both sides. And then divide by 7. So x squared equals 1. To find x, I take the square root of both sides. So x equals plus or minus 1. Number 3, what's the first step? Yes, subtract 5. What's 21 minus 5? I'm having a brain cramp. 21 minus 5 is 16. Divide by 81. Take the square root of both sides. What's the square root of 16 over 81? Take the square root of both numbers. They are both perfect squares. Square root of 16 over 81 is 4 over 9. So you isolate the x squared, take the square root of both sides. Let's do a more difficult one. Let's look at number 9. Well, it's not difficult, but it's got a fraction, so that might throw some people off. What would I do first?
Minus 1.
All right, we're going to subtract 1. And then I need to get x squared by itself. What do I do to get rid of this negative 1/2? Multiply by the reciprocal. (38) times negative 2 is negative 76. Can I take the square root of negative 76? Yes, I can. Because the square root of negative 76 is the same thing as the square root of 76 times negative 1. What's the square root of -1? Square root of -1 is I. It's going to give you an imaginary number. Oh, you know what? We're not there yet. This is supposed to be -38, isn't it? So that would be positive. So we don't have a complex number yet, but we're going to get to that soon. Okay, I got this all wrong. Let's start over. My bad. -39 minus 1 is -40. Times -2 is 80. So x squared equals 80. Take the square root of both sides. What is the square root of 80? Plus or minus 4 square root of 5. We're going to get back to this next week. We will have complex numbers and complex answers on some of the answers for the quadratic equations, but we will get to that next week. I was rushing along. I was getting ahead of myself. Everybody got that one? All right. This is your assignment for today. Assignment 9, homework 3. You're going to do 1 through 17 odd. When you finish that, get it checked off, please, and then go ahead and start working on this. I want to go over it tomorrow before your quiz on Thursday. This is assignment 9, 1 through 17 odd. Label your assignments. 1 through 17 odd, and the next page will be assignment 10, quiz on Thursday. This is a practice quiz. When is our real quiz?
Thursday.
Thursday. Thank you.